Hello, everyone. Hello. All right. Anyways, Unit 3, Lesson 5. All right, we're dealing with inverses, more inverses. Remember we talked about inverses, and one-to-one functions is a function inverse. So we'll get right into exercise 1 when we're looking at a linear equation. So we have two lines graphed. One is y equals 2x minus 4. The other is y equals x. And you can see that they're labeled because you have two lines on the same graph. So how can you quickly tell that 2x minus 4 is a one-to-one function? Because it passes the horizontal and vertical line test. So that would be the answer to part A. So you have to write down horizontal and vertical line test. It passes. All right, if I write it, it's just going to be chicken scratch. So graph the inverse of 2x minus 4 on the same grid. So all you're doing is switching the x's and the y's. So when I switch the x's and the y's, this coordinate up here is 5, 6. So I have 6, 5. Okay? This one is 4, 4. And it's right on both lines, so it just stays there. 3, 2 becomes 2, 3. 2, 0 becomes 0, 2. 1, negative 2 is negative 2, 1. And then I have 0, negative 4, which is negative 4, 0. And then this last one down here is negative 1, negative 6, which becomes negative 6, 1, 2, 3, 4, 5, negative 1. Okay, so here is the new line. And again, you have to have arrows on it. Okay, so we just switched the x and the y's and we did it. What can be said about the graphs of y equals 2x minus 4 and its inverse with respect to the line y equals 7? It is reflection over the line. So see what I mean? I can't write on this. Reflection over y equals x. So that's what an inverse is. It is a reflection over the line y equals x. Very important. Find the equation of the inverse. So we'll go back up here. So the equation of the inverse, I'm going to use this point right here. That's the y-intercept, which is 2. The slope is up 1 over 2. That's all you have to do. So the slope is up 1 over 2. The y-intercept was 2. Done. Y equals 1/2 x plus 2. Don't worry about this form. In letter E, we won't use that. As we can see in part E, the inverse functions include the inverse operations, but in reverse order. This gives rise to a simple method of finding the equation of any inverse. Well, I don't really want you to just simply try to remember about signs and functions. And what we're going to do is we're going to follow the process. So that means that when you want to find an inverse, what you want to do is just like when we graph, we switch the x and the y. So we have x equals 5y minus 20. This is our process to find the inverse. Okay? So that's step 1. Now solve for y. So I have x minus 20 equals 5y. Divide everything by 5. And I have, I ought to have this. Okay. X over 5 minus 4 equals y. Now, if you look at the choices, are any of them exactly the same? No, they're not exactly the same, right? So this part right here is also 1/5 x. So 1/5 x. And what did I do? Oh, and this was plus right there, plus right there. Okay, because when I added the 20 over here, I put the subtraction instead of addition. So 1/5 x plus 4, y equals. Okay, and then when you graph those, you can see that it will be a reflection over the line y equals x. And now we just have more practice with inverses. Which of the following represents the inverse? Which represents the inverse? We simply, again, switch the x and y. So x equals 2/3 y plus 8. So I have x minus 8 equals 2/3 y. Now, to get rid of this 2/3 y, what I do is I multiply by the reciprocal. I multiply by the 3/2. So when I multiply by 3/2, make sure that each term gets multiplied by the 3/2. So what will happen, it will cancel over here. You're left with a y, you got it. Okay, and then a 3/2 x. So gone, gone. Okay, 3/2 x, 3/2 x. And then 3/2 times -8, if you need to put it in your calculator because it has to be distributed through, gives you the -12, which is choice 2. What is the y-intercept of the inverse? So again, we're finding the inverse, switch the x and y. X equals 3/5 y. That's a 5, Chloe, minus 9. So 3/5 y minus 9. Bring the 9 over. I have x plus 9 equals 3/5 y. Multiply everything by 5/3. So you can see I'm looking for a y-intercept, not the equation. So we have y equals 5/3 x. And then this side here was multiplied, see the 5/3. So went to the x and the 9. So then we have 5/3 times 9, which gives me 15. So the y-intercept is 15. Okay? And in exercise 5, what happens here? We have point slope form. So we want to find inverse, plotting it, do not change just because it's linear, written in a different form. All right, so same exact process. X plus 6 equals 4y minus 2. Okay, so following the exact same thing, solving for y. So here it gets to be a little tricky. So we would divide everything by 4 first on our way to get y by itself. So we have x over 4 plus 3 over 2 equals y minus 2. So you see the form that they have here. They have it in the form, well, actually, I didn't even have to distribute, okay, because the 1/4 was out front. So I distributed it through, got the x over 4 plus 3/2 equals y minus 2. I was going as far as to say to get the y by itself, but they want it in point slope form. So if you have it in this form right here, we have the y minus 2, so we can get rid of these two guys. And then the 1/4 that we distributed, the 1/4 was positive, so it's this right here, because this part is the exact same thing as that part. Okay? And you have the y minus 2. So sometimes you're going through it and you have to go as far as you think you may need to. Okay? So in exercise 6, which of the following points lies on the graph of the inverse? So we have this right here. Now, this is point slope form. So the slope is 5, and a point on the line, all right, this is my x, is -2, 8. Okay, that's a point on the line. So the first thing you want to look at is if the inverse of this point is one of the choices. And remember, when you take the inverse, all you do is switch the points around. So I have -2, 8. Therefore, I have 8, -2, and there it is, choice number 1. If that was not a choice, you would have to take the inverse and then plug it into your graph and see which point was on it. And the last one, this is a quick video. Someone requested a quick video. All right, it might be about 10 minutes, which isn't bad. Which of the following linear functions would not have an inverse that is also a function? Well, what we need here is a linear that fails the one-to-one function test. So remember your functions, y equals x, yes, one-to-one function. I'm not going to circle it because you might think that's the wrong one. So y equals x is good. 2y equals x, that's good, that's a line. Y equals 2, that is also a line, okay? But what happens there is, so this is my x, this is my y. Y equals 2 is like this. Okay, that's y equals 2. So that passes the vertical line test, but it is not 1-to-1. So, because if I do the vertical line test, look, it's all right there. Okay, I'm sorry, horizontal. Vertical we passed. That's your horizontal line test. Okay, so every point is on there, so it's got more than 1 point, so it fails 1-to-1. So, which of the linear functions would not have an inverse that's a function? It would be this one right here, because its inverse would be a reflection over the y and y equals x, which would be perpendicular like this, and it would fail the vertical line test. So choice 3 is the one that would not have an inverse that is also a function. So, all right, we will see you in class tomorrow.